It's closed, huh?
Yeah.
Okay, this is your typical Lycoming timing gear, your cam gear, and your crank gear. And what you're gonna do is you have an idler gear though. That's right, you have an idler gear in between. So there's marks on the gear on how to line it up, and that's your timing. Well, we call that
Is it like the nuts?
part two. So what you'll have is you'll have a where the teeth mesh, you'll have maybe a dot here, a dot here, and a dot here. That's how you know you have to put it back together. But those are very difficult to look at. And guys have been making their own marks on it. Don't do that. There's an original mark on there. You gotta find it. Okay?
Cheaters, oh my god, how make their own mark.
You might get it together wrong, that's why.
Can you make it easier to see?
Yeah? I'll come to each group. Okay, so there's two tiny marks. One, the either gear's got 2 marks on it. The crank's got 1 mark, and then the cam's got 1 mark. So don't try to make your own marks, just to make, it's not gonna go back together right. The other way we did it in my engines, we never had marked teeth. So you had to put the crankshaft at a certain, wherever the valve would open, wherever the intake valve opened, that's how we used to use. So you set the crank at the crankshaft degrees of rotation, where the valve would start to open, and then you turn the cam and you put a dot indicator on the lifter. And as soon as that dot indicator indicates like 1 or 2 thousandths, that means the lobe is starting to open the valve. Slide the gear on.
Harder.
Yeah.
Yeah, that was hit and miss, and then you have to back it up and try it again. So you have to do a couple trial and error until you get it right on the money. We didn't have hydraulic lifters either. We had to adjust our valves all the time. Same thing. And okay, how about a radial engines? What do they have? The Hoppo's got cam shaft. Cam ring. Cam rings. I'll try and come up with a picture tomorrow. But everybody go down to the, if you want to know what a cam ring looks like, go down and look at the cutaway, the radial cutaway. That's one of the things you're going to have to point out. Where's the cam ring? Just follow the push rods. The push rods will come down and you'll have a roller tappet. The tappet will be on the cam ring. The cam ring will have 2 rows of lobes. One will be exhaust, one will be intake.
On 126 there's an image of it.
126? 126, that's on.
Yeah. Camera roller, low green.
What page?
1-1-26.
1-26.
The jet filter.
140. Figure 140. Yeah.
Yeah, roughly a form right here. Doesn't show the whole ring, but that's what it looks like. We've got a cam mold. It's the roller, cam roller or roller lifter. Goes up, hits the push rod, goes up, hits the rocker, and so on and so forth. Downstream. That's a good diagram.
Interesting.
Okay, because the radial edge is a unique specimen, on their cameraing, I never got too deep into radials before, so I'm not sure exactly how that works, but the cameraing is pretty loose. So when you do it, when you adjust valves, your valve clearance, which we're gonna talk about a little bit, there's a special procedure to follow. So you gotta preload. You had a ring here. Say this is the ring, I didn't, you gotta preload the cylinders down here so that it forces this cam ring up here, and you can adjust this one over here.
Like the wheels on a car, I mean the lugs on a car.
Yeah.
Wheels
I'm
on.
not sure exactly where you're going with that, but. Sorry. So you preload the camera, because the camera is floating, it's got a lot of clearance in there. And to get an accurate adjustment on your valve stem, you need to do a certain procedure. That's all you really need to know about that. You don't need to know too much about it. But they call it the floating camera. The best description is in the 8083, I'm not sure what page, but, the reference I had was AC65. You might have it on a worksheet. That's the reference for it right here. Or 8083. I'm not sure the pages. That'll describe the procedure for. No, for you might need that for one of your worksheets. I'm not sure. There's a couple of worksheets that will do the camera. So that's where you get your. We don't need to talk about it. Not gonna be too much on the test, other than understanding that there is a camera. Your worksheets though have probably an exercise for you to do.
119 or 80.
119.
Yeah, it's basically just the colored version of the one from the jet book.
So that's a reference. But there's a procedure, adjusting valve procedure. It's probably in the 83 someplace.
1-9.
One. Okay, here's kind of a unique thing. Okay, anybody, there's gonna be a couple places that engines break in when you first run them. Obviously, one is gonna be the pistons and, the piston rings and the cylinders, that's a major one. There's a couple other places. the other place?
Valve.
Valves, yes, the valves break in. The valve seat, the valve to valve seat will break in. When we get to that area, we'll talk a little bit more about that. But what, and one more place.
Throttle body?
Just didn't hit.
We need a cam
The cam and lifters,
Yeah.
the
Oh.
cam and lifters break in. So there you got your lifter crown. Look at the measurement. 2/1000 of a slope, convex. Not concave now, convex.
Oh.
Okay, now look at the lobe of the cam. Can you see that? No, you can't see that probably. So, when that cam is brand new, and that lifter is brand new, what they do is they have, a lot of times they'll have a cam lube that they put on, a cam lobe lube, break-in lube, and they'll smear it on the lifter and the cam lobe to help it break in. Because the cam is supposed to be able to spin that lifter. And at least one group I looked at, I helped out, there's circles on their lifter, right?
Yep.
After inspection. It's in the Lycoming overall book, it shows you 3 pictures of the surface area, right? Again, you can use those fancy words on that one page. Probably erosion, right? So what you want to look for is you want to look for the surface of your lifter should look like that. Something similar. So that shows you that the lifter is turning in its bore. And the cam lobe, every time it hits it, it's supposed to spin it.
So it's kind of rotating.
Yeah, it rotates in there. If you see a lifter like this, that means that it isn't spinning. It's opening and closing, but it's not spinning. I got a bunch of them, when they take a break next door, I got a whole bunch of broken ones that came out, that my friend found. Okay, so this is what you're looking for. And you don't want bits and chunks taken out, right? So that's the surface area. You gotta look at the surface area, make sure it's clean. If it's good, it's good. If not, you gotta put down what you see, right? Remember that list of, find a good word that matches what it's supposed to be. And then you also look at this. And you should have a convex surface. So what you do is you put a straight edge over, put it out to the sun, and you should see light over here, right? If you don't, the thing is wearing out. And it'll even wear out to the point where it's concave. I think it's really bad.
What would cause it to not rotate? Would it be just like carbon buildup or?
Well, in reality, it's always supposed to work, but obviously some break, some don't work. Whether they were manufacturers made, I don't know. I don't know what causes it. Or what causes it to fail. I can tell you, mechanic-induced failure, if you mix up your lifter, because once you have that lifter is matched to the lobe, that's a match set. So if you mix them up, they have to break in all over again. So that's one thing. So if you find a bad lobe that's worn out in your, say Well, in the old days, you buy a cam and lifter kit. And if you have one bad lifter, change them all.
Change the whole.
That relights your engine. They used to have, take the radiator out, and then there's a hole in the grill that you can slide the cam in. So you can change the cam and lifter and do a valve, take your cylinder heads off while the engine's still in the car. And you pull the cam off from the front. Put the new cam in, drop the new lifters in. You got a brand new engine almost. Depending on the pistons up. So cam and lifter kit. So you cannot change one lifter. You change one, you change them all and the cam.
And the cam?
And the cam. It's not that expensive compared to what trouble you pay me now, pay me later. So it's a match set. Always know that it's a match set. Now, will it always break? Not necessarily. I've seen guys change them all the time. But the potential to fail is there if you mix them up. That's a match set. That's a break-in. So break-in, valves break into the seats, cam and lifter break in, cylinder rings and cylinder break in. 3 places to break in. The main one, of course, is the rings to the cylinder. So the industry has, you put like a molly loop. I have a little, if you buy a cam and lifter kit, they'll give you a little disc full of molly lube. And you just smear it on. And that helps with the braking. Now, Lycoming, they don't have lifters anymore. They have roller lifters. So it's a roller. It's like that other picture I had of the cam ring. They modify all the way. Everything comes out of Lycoming now is roller. They don't have the traditional lifter like this. And you can modify your existing cases. We had a student here that was he was a bush pilot up in Alaska. And he came down to take the class so he can get his A&P, because he was paying all these guys to work on his airplanes. He said, I want to work on them. And he has A&P, so he came here, and then he overhauled an engine here, in his back porch of his apartment that he rented. But most of it was sent to Lycoming to do some modification. They sent it back. He saved $10,000 doing most of the work himself. So I thought it was great. He gave me all his old parts to help me with all of our spare engines downstairs. So I got a couple of stashes there, especially when we want to run the engine. So this one I got, I forget where I got this one from. This one is from automotive. Same thing though. So that's your inspection process, so you can inspect all your lifters. I'm not sure if there's a slot on your paperwork for it, but you can check that. This is a couple other things. Edge loading caused this. We have a This is what happens when used lifters are used on a new camshaft, courtesy TRW, replacement division. So, there's a lot of interesting stuff that you, I know I found this in my machine. I have a automotive engine machining book, textbook. And that's what I taught from before. So I taught engine machining too. A little bit sidebar.
So are they supposed to wear out like the same
Pace.
Yeah, the same base, that's why you're saying that you change the lifter, might as well change the cam.
You should, all lifters. You're not supposed to change just one lifter.
Because they break in.
They break in. You can't re-break them in.
Okay.
Just like putting an old set of piston rings back on and expect it to break in. They don't have the contours to help it break in.
Right, okay.
At 2000s at an angle,
Yeah.
it'll be flat now probably.
Like only buying a one left shoe.
So you always buy set lifters.
Yeah. One of those two.
Set lifters, one camshaft.
Can you resurface the internal the cylinder, like sleeve, or is it just cheaper or?
Oh, that's a good point, I forgot that too, that's a good point. Okay,
Wouldn't you sleeve like That's not big.
the cylinders.
Before you do that. They should have-
Save money too.
You know how to do it.
You got chrome,
Sorry, it's a-
the cylinders, you got chrome, plain, and nitride, right?
Next try.
If they wear out, what can you do to repair them?
I think you would resurface them, but then you have to re-harden it, right?
You can go, so I think there is a process for oversize, for the nitride and plain. What about the chrome?
Chrome.
Yeah, put new chrome. Chrome is plating,
Right.
Yes, surface.
that's applied to the surface. Nitride is surface conditioning, so it goes deeper, right?
Yeah.
So you can't really, you cannot put more metal on there and do it again.
Yeah.
The only thing you can do is go oversize, or buy a new cylinder.
Or so oversized, go bigger, right? But
Yeah, oversize, you gotta get oversized piston though, by right?
Yeah.
And oversized rings. What, pain in the butt, right?
Then the better one just like.
And then you gotta know which cylinder that is. So usually it goes back to better buy all keep it standard. Just give it the R&R, that's why you got the R&R business. You always have a couple of cylinders on your rack so that in case that you know fit and are correct for your engine, right? Or the engine that your company's running.
I was just
That's-
thinking cost-wise, would it be, is it more efficient? But,
That's economic decision, right?
yeah, that's.
Owner operator. Okay. We'll go to the lifters now.
If I was to do it myself, if you're a business, if you're going, I don't have to fix it.
I've got a video, it's about 15 minutes long, about lifters, hydraulic lifters. Everybody wants to know about hydraulic lifters, how they work. Okay, we have the 4 engines that are on that side of the hangar are all hydraulic lifters. The one over here is solid lifters, where you have to hand adjust them. Okay, hydraulic lift is automatic, everything's done. You know, once you put them in, that's it. No adjustment. Much less maintenance. There's the internal guts of it. How does that work? Very difficult. The video's going to show you. I think it's a valid video. It's a little bit long, but it's valid. It's from Chrysler. It's an automotive type, but it's the same thing. It works the same way. So the understanding of it is going to be really good on the video to understand what it is. But first, I got to brief you guys on what is hydraulic lifter. Why do we have hydraulic lifter? Okay, when you're gonna put the engine together, your engine together, you're gonna drain your lifters, get all the oil out. And that's the only way you can adjust it. And there's a spring, it's spring loaded here. There's a spring, so you can compress it all the way down. But otherwise, in lieu of that spring, the oil is inside the thing. And there's 2 pieces. Did you guys, any of you guys took the spring out of the other cup? Took the spring out?
Okay, fair.
So you got the socket, right? The socket came out, right? then the spring assembly came out, and did you separate the spring assembly?
And the two little collar looking things.
Okay, those two things will separate. And inside there is an oil. And so what happens is, the cam lobe will come up, depress this, and there'll be fluid in here. And that, the fluid being trapped in there will be the pressure pushing on the push rod that pushes down the spring and the valve opens the valve. Okay, as it's opening, the oil is bleeding out between these surfaces in here, these clearances. And so it bleeds down a little bit. But then when the cam lobe goes off, it'll fill back up again. Yeah, the spring will make it expand again. And it'll suck more oil in there. So every time the lifter works, it compresses and bleeds out a little bit. And then when it goes back around, it sucks more oil in, so it's ready for the next time. That's I'm trying to give you an overall view. And when it fills back up, there's no clearance between the valve train. There's no clearance. So let's see. Let me see if I got another picture over here. I don't have to draw it. Otherwise I'll draw it. Okay, normally, on the 0235, if you guys get a chance, go look at the difference on the group that has the 0235. Here's your lobe, here's your hydraulic lifter, well, here's your lifter, here's your push rod, and up here there's an adjustment nut. So there's going to be a clearance in there that you have to put 5 thousandths, sometimes 10 thousandths, depending on the engine model. So every time the lobe comes up, it bangs on the top of that valve. That little clearance, it's always a little bit of clearance, so it's always banging on it. So it wears it out a little bit prematurely sometimes. But a hydraulic lifter, it takes up that clearance. So when the lobe comes around, it doesn't have to bang on it, it's automatically got pressure, it just pushes. So that's the difference.
More like,
How much oil do you think is in there, Mr. Mike? Like,
It's just a little vial, it's only not even a square half an inch. I mean, cubic half an inch.
that's hydraulic?
Well, that's your engine oil.
Oh,
So
okay.
you call it hydraulic lifters. Hydraulic is liquid, right?
Yeah, but it's like a articulating, it's like a, versus it tapping, it's just
Yeah.
rocking it.
They say it's supposed to clearance.
Huh?
It's like smaller.
It's just the spring,
It fills in the gap.
spring in there. You mean what takes up the clearance, the hydraulic lifter?
Almost like it's already there, but also pushing.
Yeah.
Right. But it does.
yeah,
They're saying like from the top.
Yeah, this is all touching all the time.
Yeah, because of the hydraulic.
Right, because the hydraulic fills up, but only enough to close the valve. The pressure of the valve spring will close it.
Right, yes.
But there'll be no slack in the link, all the linkage.
That reduces the friction.
That reduces the pounding,
Pounding.
the pounding on
You can
it.
call that.
So that's why hydraulic lifters are way better.
What can you call it, bro? Thinking.
And what they do, since it's a zero clearance, they call it zero lash. Zero lash lifters. That's the nickname for them. So when you hear zero lash, lash is the clearance. So there's no slop in it. There's no clearance in anything, so it's zero lash.
Oh, yeah, there it is.
That's also why when you guys were taking apart your engine, and these engines have been taken apart and not run, so that all motors are typically empty. They're not gonna fill up with oil unless you start the engine and get oil pressure. Okay, so when you take that cylinder off of an engine that was running, or if you're doing a cylinder change on an airplane, you have to put that piston up at TVC compression. Both valves are closed, zero lash. So you should be able to put a thumb push on that rocker, the rocker shaft, and get the rockers out.
Somebody got stuck there.
Otherwise
Is it zero lash? So there was no pressure on the valves. Okay. So you need, obviously ours, our bronze bushings in the cylinder head are all marked up a little bit, so some of you guys had to drive it out with
Yeah.
them. Some more than others, right? Supposed to be a thumb push or a pinky push. If everything is working correctly, right? And I try to fix them as we put it together. I'll try to come up with something to fix it, especially the one that's missing a whole bushing. Okay? So that's the reason for the hydraulic lifters. And I'm going to play the video after the next break, I think. I want to see how far we can get today. Lifters or tappets. Lifter or tappet, solid or adjustable. Hydraulic, less maintenance. My engines, we had adjustable. We were adjusting them every couple of nights. The valves have always got out of adjustment.
That's just from operation.
Just operation, yeah. But to keep that engine running smooth and power and all that good stuff, keep those engines running nice, and keep those valves adjusted. VW is adjustable valves, right? I don't know if they ever came out with hydraulic lifters. I did old stuff, old guy.
They probably do now.
So. The thing with air-cooled engines though is that, at least with the VWs, I think, the expansion and contraction of the engine was bigger. The engine runs harder. I'm not sure if that plays into it. That's a little bit sidebar.
That is directly.
So remember the push rods are also hollow, right? They carry oil. The oil gets into the lifter right here, right, to this groove. And the bore of the block has an oil passage. So oil transfers into the lifter. And it also works the hydraulic, but it also gets directed up through the push rod. Up to the push rod. You look in your rocker, there's a little hole in your rocker. And it's got a drill passage, and it comes up and it lubricates your shaft, with your rocker shaft.
That's it.
And that's pretty much the extent of the oil pressure. We get the lubrication, we're gonna trace the whole system, the whole thing. Okay, some of it'll spill out and probably keep an oil bath in this area. And then you had your drain tubes, right? The drain tube that came down to the back to the crankcase. Some of you had drain tubes, some of you never did.
It is connected.
Yeah, because as the oil is lubricating, it's dripping out of here, right? So it's going to accumulate in the rocker box cover.
Go back to crank.
So it has to go back down to the crankcase. So that's why you have the drain tubes.
I guess oil is important.
Made with aluminum or steel with pressed ends on it. So these ends are pressed on there. So when I used to inspect mine, I would take them to make sure they're not bent. I put them on a flat surface like the granite table, and I just roll them. They roll nicely, good, they're not bent. And then put my fingers on the ends to make sure they were still tight. Sometimes I found a couple of loose ones, get rid of it. I had that one time, we had a push rod failure, no, we had a rocker arm failure. They had the emergency land on one eye. And they couldn't taxi because one engine wasn't working. You need two engines to taxi this kind of airplane. So they pulled over into the pineapple field. That time they had pineapples over there. So Mike, you gotta go over there. Well, okay, so I'm over there with my, when it's a rough running engine having to do a cylinder change, I gotta bring 9 toolboxes.
Nine.
9. I had a spare cylinder, piston, and then all the special tools to do the cylinder change. But that's the worst. That's the worst they can have is change cylinders. I did that a couple times, but. So I get to Lanai and I guess one of the rocker arm failed. First thing I did is open up the rocker box cover to take a look. Sure enough, I could see the damage in there already. So I ended up just putting a new rocker on and a push rod, and off we went. I was in the pineapple fields with bugs and everything.
How long did that take?
But that was pretty quick. That took me about an hour or so. And I flew back with them.
Well, when majority of the time when you do those off-island maintenances, you're by yourself.
Yes, I was by myself.
What if you need
A
one?
typical cylinder change is about 4.5 hours.
Alone.
By myself, yeah. I did Maui, I did it to Maui, I did a double cylinder change. They had a damage in one cylinder, blew a hole in the next cylinder. So I had a double cylinder change.
So if the push rod is bent, you just gonna throw it away, or you can press it?
What's that?
If the push rod is bent like that, you can just throw it away,
Yeah,
or
throw it away.
you can just press it?
Oh, you're not gonna, I wouldn't put that together again.
Or you can't down, kind of face them.
Yeah, I don't know, you gotta make your judgment out there.
The push rod snap, that sounds like a bad thing.
You can pay me now, pay me later, you can pay me now and later.
Oh, job security.
You always err on the best judgment, err on the side of new, unless you get plenty experience on it. I know what it was the rocker they had a bracket that held this rocker onto the cylinder head. The bracket had two bolts, or two studs sticking out, and you would put nuts on the bracket. Well, the stud had sheared, the stud broke. And then, when we went back to the shop, I told my boss everything was going on. He goes, okay, look back. It was a mandatory to change the stud for better studs.
Mr. Mike,
So then he had to go change all the studs on all the cylinder heads. Pain in the ass. Yeah.
was the stud still in the,
It was rolling, it's an inline engine, so the rocker box covers were on the bottom. So everything fell to the bottom.
oh, okay.
And the rocker box had a oil level in it too. That's how it got lubricated, all the valve mechanisms. Was in a bath.
You have to fish it out.
So yeah, I had to take that out. You gotta pour more oil inside there, put it back on. So I just changed the bracket and the stud, and then, I don't think I changed the cylinder. I know I didn't spend too much time in the pineapple field.
How did you find that, that it was mandatory to switch the boat out, just hours?
We look back on we had a thin overhaul manual that was similar to the Lycoming overhaul manual. And then we had a thick book that had 3,000 modifications to the engine. Some mandatory, some recommended.
Control F inside there.
There was no ADs though, it wasn't an AD. It was just manufacturer recommended. AD you gotta do no matter what from FAA, right? So we weren't necessarily in violation.
So it's not gonna be alteration?
It wasn't a major repair alteration. It's just a new part. It's like Lycoming says, okay, we're not gonna use these studs anymore, we're gonna use these studs now. New and improved, because we had problems before. And that's what the service bulletins come out with. They'll give you a
Service
procedure for
bulletin.
doing it, they'll give you the part numbers, how to order it, all that kind of stuff. And that changes the parts book.
If it's a service bulletin and it's, the parts are, yeah, if it's listed, then it's fine, right? You know?
Service bulletin is typically a mandatory though. So you're supposed to follow that. So in other words, if FAA comes, have you done all your service bulletins? Oh, no, where's your record? Let me see.
So that's where they messed up with that boat.
Yeah, they should have changed it in doing the cylinder head overhaul. But they never did, whatever. So if FAA investigated, something got hurt on that, guarantee investigations.
But if you never got the letter.
That's why
And
it's
then-
supposed to
then
keep
they got-
up with it, that's where it's there.
So I know of no shop that is an angel.
Right.
I'm doing everything correctly. If you attract FAA, they're gonna find something. So the idea is never to attract them. Right? And it's not like you know something's bad and you didn't do it, but there's something you may not know that's what's exactly what, and each inspector might be thinking that a little differently. We had an inspector used to come visit us all the time. I got plenty more stories that evaded FAA for. I was not in control of my life. Okay, talking about valves a little bit. Camshaft, let me see if I got everything lifters. I'm gonna show the video. Let's see if I'm gonna finish up valves. Valve guys. Valve nomenclature. Well, I didn't put any nomenclature on here. I think everybody knows what a valve is. Here's your valve shapes. They're all valves. They all do the same thing. Open and close that air and gas, exhaust, or intake in and out. I think most of you have out there for the Lycom is flathead. Semi-tulip, got a little dish in there. On the bottom of the valve grinder, we got a box of all kinds of valves. Just look at that if you want. Semi-tulip, a little bit dish, tulip, and then mushroom head. So on worksheet 4-5 and 4-6, if I'm correct, it's all about the valve grinding. That's a separate lecture. And then I'm going to demonstrate how to cut the valves and how to cut the seats. You do not have to do them as a group. Probably gonna laugh though. I'll teach you how to laugh. That's when we get to overhaul. Okay. So don't worry about 4-5 and 4-6 just yet. I'll have a separate lecture just for that. Then I'll go outside and we'll do a demonstration. Yeah.
Are the valves concave for space saving or for a different reason?
Ooh, good question. I don't know. Some of these valves, which the next couple of shots are going to show, they have sodium inside. The exhaust valves have sodium inside for cooling. So it could be having to do with cooling temperature of different shapes.
That makes sense.
Yeah, I don't know the design features, all the background on them. Typically, the light coming or the small engine is all going to be flat. Only the big radios I've seen with this kind. Split key or keepers, as they call them, keepers. And this is also a match set. These two keepers are not supposed to be mixed up. They have been mixed up with your engines, don't worry about. I cannot control that. That's what I mean about controlling an engine to make it run right. On my engines, we had a little serial number up here. The two serial numbers had to match. It was right up on top here. So that you couldn't mix them up. You just look at them, you can match the serial numbers. Because what will happen is, both of these are holding this valve into the spring, right? Okay, what if one of these is worn out a little bit more on one of the edges right here?
Oh, good, not gonna stay.
No, what's gonna happen is, you put them together, only one keeper's holding. The other keeper's not doing anything. Because one is worn out more. So now you only get one keeper holding it. So that's why it's always a match set. Until it's time to change, you change both. My Comey doesn't serialize them, but mine had serial numbers on top. Never forget that. Okay, keeper. The tip, this is called the tip right here. Okay, I think there's gonna be another sheet. Valve spring retainer. You guys all seen this already, so. Double spring. Why we got double spring? In case one breaks, yeah?
Redundancy.
That's a sidebar, that's not the purpose of it. That will keep the valve working. But the reason is, and they're wound opposite. You see how they're wound opposite?
So they compress the
Well, it's a standard pressure or whatever it is. What will happen is, at very high speed, if you only have one spring, you have a tendency to valve flow. They call it valve flow. It's in your textbook, so you guys wanna read that stuff up a little bit. But what'll happen is the valve won't actually seat. It'll float. It goes so fast. So if you have two springs, it'll actually hit the seat. Better operation. Right, better volumetric efficiency. Ultimately. Valve guide, these are press fit. I'm gonna show you guys how, when you guys start doing that, nobody's really measured the valve guides yet. There's a couple of go-no-go gauges. You got a couple of go-no-go gauges, otherwise you use a small hole gauge. The T gauge will fit into, the small T gauge, so you can check the diameters in there. And, but the go-no-go gauge is when you have like 10 heads, you're gonna do a go-no-go gauge. Or as we say over here, can gauge, right? And here is your, I'm not gonna go too deep into the angles and everything yet, that comes when we go to the overhaul. Just understand, this is the head, the whole head, the neck, the face is where the actual contact is the face. Wherever it makes contact with the seat is the face. This one is a sodium, typically on exhaust valves. Some of you have sodium filled exhaust valves, some do not. They're just fatter. They're way bigger than the intakes. Whereas if you have a non-sodium filled exhaust valve, they're about the same size. Intake and exhaust will be the same size. So I'm not sure which one's out there. Probably the ones with the higher compression cylinder pistons will probably have sodium filled exhaust. That thing runs hot. And this is hardened tip. What's a real hard metal? Real hard steel?
Carbide.
Huh? Carbon?
Carbide.
Carbide? Hard? What's another one? Chrome? Chromoly? I'm gonna write this down, don't forget this one. Let me try to spell it right. Who said that? I thought I heard the word. Anybody work with engines? Hard steel. Stellite. A lot of the seats are made out of stellite. No, that's tough. That steel is tough. That thing will outlast the cylinder head. So, what they do is, they'll put the tip up here. Stellite tips, stellite face, and stellite seats.
Mr. Mike,
That'll give you a really tough engine, yeah.
so it's not a super hard, it's like just, it's cobalt.
I don't-
Because since it's impacting so much, if it's like brittle steel.
I don't think it's brittle, I think it's tough.
It's cobalt and chromium.
What did it say?
Stellite.
Stellite is made out of what?
Cobalt and chromium.
Cobalt and chromium. Cobalt is super hard. It's not as quite as hard as carbide, but you mix the two, they come up with they give it a name stellite. That's just a mixture or a
Does
mixture
the
of.
chromium make it brittle?
I'm not really a metallurgist, so I don't know about telling about that. But if you looked up, I bet you if you looked up more on, Stellite, that's kind of cool to look up, I might look that up myself.
Machine gun barrels.
Machine gun barrel, Stellite? Stellite is real common though, so if you look real closely with a magnifying glass, you can actually see where the metal molds to the stock metal of the valve. And at the tip too, you can see that. If you look, there you go, magnifying glass though, a good one. You might be able to see it. Right where the two different metals join. Really good process, so. Stellite.
That's a process.
Yeah, so what'll happen is that rocker, especially if you have solid lifters, this tip gets all mushed up. So you can resurface that on the valve grinding machine. I'll show you guys how to do that too. After you get out of here, you guys can do your own valve work on your car, you know. It's the same thing. It's the same thing. You gotta get the tools though.
Yeah.
But the tools are relatively cheap. It's not you don't need a machine. You just need a fancy drill. Oh, lots going on over there. Don't you have that, one of your worksheets to do that? Name all the parts?
Yeah.
Yeah. That's a good sheet. You gotta look real close though. If you're smart, you get the right parts breakdown. One of the manuals inside the toolroom's got it. Oh, that's cheap. Okay, on your sheet, still on the topic of the valve train, is on your sheet, there's no provision for you to check springs. In other words, no blank to fill in. But you should be able to understand how to check the spring tension, your valve spring. We have a spring tensioner machine. I'll bring that out. As we get closer, I'm gonna bring some things out so you guys can use. You guys get your springs, come to the table, I'll show everybody how to, simple use.
Just comparison and gauge.
The big thing that the learning part of it is I want you guys to be able to interpret the specs in the book and understand what they're talking about and how to apply it to the tester and get the accurate indication. So it's all about, and that goes for any spring. It could be a spring out of a valve, and if you're doing an overhaul and you have the manual for it, it says it's got to be so much tension at such a height. So you compress it to a height, and you see what the tension is, and you're good. Or you got to go buy a new one. Let me just tap it a little bit first. Okay, still, it's very difficult to explain how this thing works. I think it's a good thing. That's why I'm gonna show the video. So I'm just gonna show these couple slides, and we'll take a break, and then we'll come back together. I don't know that you're not gonna be tested on it too much, but you gotta test the overall theory, the big picture. But I think it's a good idea to understand how the thing works and the background of it. Now these two pieces that slide in and out of each other, the spring mechanism, not the socket now, and not the whole thing in the tapered body, but the parts with the spring, the other parts that come apart. That's got about a couple of 10,000ths clearance in it. Those are very important never to mix up. Because what will happen is that you guys saw in your textbook, I mean your overall sheet says bleed down rate. Some of you guys are talking about that, right? Bleed down rate?
Yeah.
Okay. Lycoming you don't need to do a bleed down rate. All you gotta do is put your finger on there and make sure that there's a process in the overhaul book that tells you how to inspect it. But we have the bleed down, we have the bleeder downer, whatever you would call it, the machine. It's an automotive one. But all it is comparing one to the other. So you put down, Okay, 1, 2, 3, then it's collapsed. Next one, 1, 2, 3, okay, that one's not, all of a sudden, that one collapsed immediately. So guess what, that's not gonna hold up. The cam lobe comes around, it's not gonna be able to open the valve far enough or long enough. Right? So that's why you need the bleed down rate, to make sure you get enough hydraulic pressure for the period of time necessary to keep the valve open and closed. So that's what the bleed down rate, so we'll show you how to use that. If you also want to know how light foaming does it, so they put it all on a line, there's a picture in the overall book. Okay, so that's the bleed down rate, so to speak. And that's why I got another set, so if one of those are bad, like when I put that other the other 0320 running that's on the stand now, I had to go get all the best ones I could find. I'm gonna buy that kind. And here's your rocker. There's your drill passages. The belt grinding machine also will surface this area too. Got a nice rounded surface. Here's your oil. And what they do, here's a little plug. They drill this whole rocker all the way through. And then they plug this over here. So the oil will come up here, go up to this passageway, and then turn right, and come down and lubricate the rocker shaft. Okay, I think one of you guys had a hard time taking the rocker out. Is that you guys? And this thing from here to here, it's got to be a certain thickness, so it fits in the cylinder head between the two aluminum bosses area. So if that's bad, I'll show you guys how to fix that. Okay. And you put a feeler gauge in there between here. Put a feeler gauge on one side of it, and that's what they call side clearance too. So there's a spec for that, but not on your overhaul sheets. Yeah, the rocker, you put a feeler gauge in between here. So that rocker should slide back and forth, side to side. That's what I call side clearance, or side to side movement, as well as rocking. If it's too tight, it might bind up in there. All right, take a break.
Yeah.